In this video, we're going to start talking about simplifying rationals. If you remember, rationals, that's just another word for fractions. So we're going to be incorporating polynomials within our rationals. So it just starts to get a little bit more complex here, which is to be expected. So first of all, when simplifying rationals, again, we're going to treat them like fractions. So we always want to simplify our factors and cancel things out, everything that we can, and get it in as simple a form as possible. So we're going to start with one that's pretty straightforward. If we have the rational expression a times b plus 1 all over a times b minus 1, what we want to look at here are what are the factors. Remember, factors are the numbers that you multiply together to get an answer. So looking at our factors, what are we actually multiplying here? We're multiplying a. A is a factor in our numerator, and b plus 1 is a factor. This whole thing is a factor. Remember, when you're adding two terms together, it hooks them together, okay? So when we start the cancellation process or the simplification process, you never want to separate anything that is combined together with a plus sign, okay? So our two factors, a and b plus 1. So in the denominator, we have the factor a as well and a b minus 1. All right, so when you simplify fractions or rationals, you're looking for your numerator, factors that you have in common in your numerator and your denominator. In this case, we have an a in the numerator and an a in the denominator. So a divided by a is 1, which means we can cancel out the a's. We look at our other factors, we have b plus 1 and b minus 1. Everything is the same except for this plus and this minus sign. But because your numerator has a plus sign and your denominator has a minus sign, these are not identical, therefore we cannot cancel them out. So we have simplified this rational expression as far as we can. So the result is simply going to be b plus 1 over b minus 1. And if you want to leave that in parentheses, not a bad idea. But this is our simplified version. Now, of course, sometimes you are going to be given rational expressions that have not been factored for you. So let's look at one of those. If I have 3x plus xy over 4x plus xy. Okay, so we're going to have to review just a little bit of our factoring. Hopefully that will come back to you fairly quickly. If we look at our numerator, 3x plus xy, I want to see, can I factor anything out from these two terms? What can I divide both terms by? Okay, so I see this has an x, this has an x. So I can divide both of my terms by x. So when I factor out the x, and what am I left with? 3x divided by x is simply 3. xy divided by x is simply y. All right, so this in factored form is x times 3 plus y. Now let's do the same thing in our denominator. Again, I have a 4x in this term and an xy in this term. So again, they both have an x in the terms. I can divide both of these terms by x, so I factor out the x. I'm left with 4 plus y. Okay, so now again, I'm going to repeat the process that we did before in the last problem. I have a factor of an x and a factor of 3 plus y. In my denominator, I have a factor of x and a factor of 4 plus y. So which factors do they have in common? The numerator's an x, the denominator's an x. I can mark those out. X divided by x is 1. So that means that I can divide those out, and I'm left with 3 plus y over 4 plus y. And again, because these are both different, 3 plus y and 4 plus y, those are different, I can't factor anymore, okay? So this one is as simplified as we can make this rational. All right, so let's look at one that might be just a little bit more complex. 15x to the 4th y squared plus 6x to the 3rd y squared all over 6x to the 4th y squared minus 15x to the 3rd y to the 3rd. Okay, so let's look and see what we can factor out from our numerator, what can we factor out from our denominator. Let's start with our numerical values. We have a 15 and we have a 6. Well, 15, that's the same thing as saying 3 times 5. 6 is the same thing as saying 3 times 2. Okay, so I can see that 6 is divisible by 3, 15 is also divisible by 3. So I'm going to factor out a 3 first. Okay, now this is going to see, I'm seeing a lot of x's and y's in both of my terms, so I know that I'm going to end up having to factor out some x and y's. So what I'm going to do is just go ahead and kind of set up my parentheses here. Let's see if I can move that back over. And start filling in as I factor. So since I factored out a 3 from the 15, 15 divided by 3 is going to be 5. All right, and 6 divided by 3 is going to give me a 2. So I'm going to skip some space there and go ahead and put my 2. All right, now let's look at my x's. I have an x to the 4th and I have an x to the 3rd up in my numerator. So that tells me that I can factor out an x to the 3rd from both of these terms. Since they both have at least 3 x's, I can factor out x to the 3rd. So that's what I'm going to do. All right, so when I factor out x to the 4th divided by x to the 3rd is simply going to leave me with an x. Okay, x to the 3rd divided by x to the 3rd is 1. So I don't have to put another x back here with this 2. Okay. Now I'm done with the x's. Let's look at the y's. I have a y squared and another y squared, which tells me I can factor out a y squared from both of those terms. And when I factor out that x squared from both of the terms, that means I don't have to put anything back in there. Okay, so I have some extra space. So I'm going to just kind of clean that up a little bit there. All right, now let's do our denominator. All right, so I have a 6 and a 15 again. I know that I can factor out 3 because I did that with my numerator. And when I factor out a 3, that's going to leave me with a 2 and a 5 again. All right, now let's do the x's. Again, I have an x to the 4th and an x to the 3rd. Well, golly gee, I can just factor out an x to the 3rd there. I'm left with an x with my 2 this time. And looking at my y's, I have a y squared and a y to the 3rd. I can factor out a y squared, and I'm left with a y with my 5. Now, I wonder if any of you noticed, but I made a boo-boo when I wrote that plus sign there. I need to put that minus sign. Okay, so hopefully none of you noticed, but now you did, so whatever. Okay, so here we go. So now we have a factored version of our rational expression. So now let's finish simplifying this. Here's a factor, here's a factor, here's a factor, and then this whole thing in parentheses is a factor. Same thing in our denominator. 3 is a factor, x to the 3rd is a factor, y squared is a factor, and then this whole thing in the parentheses is a factor. So let's look at our factors individually. 3 divided by 3 is 1. It's gone. X to the 3rd divided by x to the 3rd is 1 as well. Gone. Y squared divided by y squared is 1. Gone. Looking at our parentheses here, I have a 5x plus 2 and a 2x minus 5. Those are totally different. So this is as simplified as it's going to get. So my result is simply going to be 5x plus 2 over 2x minus 5y. All right, thanks so much. We'll continue some more of these problems in the next video.